right, taking a look at dimensional analysis. That's a fancy way of saying, hey, I'm going to be gone for 21 days. And someone says, oh my goodness, that's great. You're going to go away for 3 weeks? Yeah, that was really easy. How did they do that? They did it using dimensional analysis. Now you're saying, no, you didn't. You just figured it out. You took 21 divided by 7, you got 3. I know, but you did dimensional analysis. In your brain, you took 21 days and you wrote it over top of 1. You're like, no, I didn't. Yes, you did. You really did this. You're a genius. And you put a multiplication sign. You wrote another fraction. You said, I want to get rid of days. I'm tired of people talking about being on vacation for days. I like talking about vacations in terms of weeks. And you realize you need to get rid of the unit days. So to get rid of the unit days, we have to cancel it out. In the world of math, to cancel something out, you can put it on the top and the bottom of a fraction. So I put days down here, and I put weeks up here. The whole reason we have this is because since these are multiplied, these two are going to cancel out. And I'll end up with a new unit of weeks. Now, I need to multiply this by something, this conversion factor, that each of them mean the same thing. What's some number I can put in here, and they mean the same thing? Well, again, you know that. You know that 1 week is the same as 7 days. What's more, 1 week or 7 days? They're the same. But what we've done is we can now cancel out both the days. I can take 21 times 1, which equals 21. I can take 1 times 7, that gives me 7. I can divide the 2 and get 3, and I'm left with this as my units, 3 weeks. So yes, when your friend says, I'm going to be gone on vacation for 21 days, and you say 3 weeks, you've just done dimensional analysis. Kind of, okay? The problem is now we have to apply that to other things. I might tell my friends, oh my goodness, I'm so full, I just ate 4 dozen donuts. That would be a lot, okay? If I ate 4 dozen donuts, my friend yells back at me, how did you do it? You just ate 48 donuts. Well, wait a second. How did they go from 4 dozen to 48? You know, you just took 4 times 12. But what's really going on? Let's take a look. You take your 4 dozen and you put that over 1. Now you're like, I did not do that, but you did. You wanted to cancel out the dozen, so you put dozen over here, and you wanted to turn it into the new thing, which are donuts. Now, what's the same between a dozen and a donut? You know that every time there's 1 dozen, it means 12. So really what happens is the dozen and the dozen get canceled. And when we do that, we take 4 times 12, and we get 48 donuts. So these are ways that you do dimensional analysis all the time. But there are things talking about vacations and donuts, and everyone loves vacations and donuts. Unfortunately, in science, we start talking about moles and miles per hour and liters and to gallons, different things like that. And boy, it gets really confusing, and now it doesn't make sense. So when we stick to days and donuts, easy. These things, hard. So always come back to these problems we did originally and think, how did I set that one up, and try to do the same? Let me show you how. If someone says, oh my goodness, I'm so tired. I just ran 6,284 feet. Oh, I'm exhausted. What does that really mean in miles? Well, we can figure that out. Some of you remember there's a conversion factor that says that 1 mile is equal to 5,280 feet. Now, we don't need to memorize all these different conversion factors. You can look those up, but we can use this conversion factor to figure out this answer. Always write down what you know, what you did first. 7,284 feet over top of 1. Now that we've done that, I need to cancel out my feet. So I'm going to put feet down at the bottom. I need to turn it into the new thing, miles. I always like to think, what am I trying to get rid of? Store it in the basement. What am I trying to turn it into? Bring that upstairs. Here's my conversion factor. 1 mile is the same as 5,280 feet. Now I can cancel out both my feet. I multiply across the top, I get 6,284. Multiply across the bottom, I get 5,280. And now I get to do one of my favorite things in all of science and math. I get to divide. And I get 1.19 miles. Oh my goodness, I should bring in another thing. If you're learning about Sig Figs, you can look over here and realize I started with 4 Sig Figs. So guess what? That only has 3 Sig Figs. So I'm going to look back at my calculator. I realize that my true answer in my calculator has another 0 there. So there it is, 1, 2, 3, 4 Sig Figs. 1.190 miles is the same as 6,284 feet. Let's try another one. Let's say you go to Canada and you see the speed limit says 100 kilometers per hour. And you're like, whoa, that's crazy fast. Well, not not necessarily. That's just kilometers per hour. We're not used to seeing that. So we want to change that into miles per hour. Now, you might think that says meters per hour, but again, we'll go with miles per hour. So I'm going to start with what I know, 100 kilometers. Now, this little, that means per, that means divide. So I'm going to put that over top of an hour. So I'm going 100 kilometers every time I go 1 hour. Now I need to get rid of this kilometer. So let's try this out. I'm going to go a times symbol, and I want to cancel out kilometers, so I'm going to put kilometers on the bottom. I'm going to go up to the top. I want to turn it into miles, so I'm going to put miles up here. Now, I need to know what the conversion factor is in between these two, so I'm going to go ahead and look that up. Now, what you're going to find when you look this up, there's a couple different ways you could write out this conversion factor. You could say that 1 kilometer is the same as 0.6213 miles. That's true. And when I do this, the 2 kilometers are going to cancel out. 1 times 1 is just 1 on the bottom. And really, I'm just taking 100 times this. And when I get my answer, I'm going to find out that I'm going 62.13 miles, because that's still left. And then on the bottom, we still have hours. So per hour, miles per hour. But I could do it another way as well. I could have my 100 kilometers per 1 hour. And in this case, I could have put 1 mile. Now, if I would have had 1 mile, that would have been the same as 1.609 kilometers. So which one is correct? Is this a conversion factor, or is this a conversion factor? Well, guess what? They both work. 1 mile is that many kilometers, and 1 kilometer is that many miles. Again, these are things you can look up using Google pretty quickly. So now, in this case, I'd cancel out my kilometers. I would take 100 times 1, which gives me 100. I would take 1 times 1.609. I get 1.609. And I'm going to divide those two. And I get 62.15 miles per hour. Not exactly the same, but close enough in our situation to realize both of these are the same type of conversion factors. Okay, this one's going to be a little harder. Let's say I take 60 kilometers per hour, and I want to change that into meters per second. Now, in this case, this is, again, more challenging, so if you're not able to do this one, that's fine, but give it a shot. I want to turn my kilometers into meters. I want to turn my hours into seconds. Now, in doing this, I've got to do a double problem, basically. So let's start off by putting our 60 kilometers per means divided by. I'm going to put 1 hour. Basically means every hour I'm going 60 kilometers. So now I'm going to write times. Let's just focus on that kilometer part. Let's get the kilometers and turn it into meters. I want to get rid of kilometers, so I'm going to put kilometers on the bottom. I want to turn it into meters. I'm going to put meters on the top. Now you can look this up online and find out that every time you have 1 kilometer, it's the same as 1,000 meters. Well, when I do the math on this, the 2 kilometers will cancel. I'll end up getting an answer that's in meters. But I still have to come back to this part. If I stopped right here, I would find out meters per hour. I want meters per second. So I need to get rid of my hours. Now, hours are on the bottom of this fraction, so I need to get them out of there. So I put the hours on the top. Now that hours are on the top, I want to turn the hours into seconds. Now, turning hours into seconds, some of you know this because you're math geniuses. Most of you don't know how many seconds are in an hour. But you do know that you could take hours and turn them into minutes. So let's put minutes here. And what's the same between an hour and a minute? Well, every time you have 1 hour, it's the same as 60 minutes. So now what's just taken place is I can go ahead and take my hours and cancel them. If I were to stop the problem right now and multiply across, divide, I would get an answer in meters per minute. Well, I want meters per second, so I better get rid of that minutes. So I need to get rid of minutes. They're on the bottom. I better put them on the top to cancel them out. I want to turn them into seconds. Now, what's something that's the same between minutes and seconds? Every time I have 1 minute, it's the same as 6 seconds. So now these 2 minutes can cancel. So now I multiply everything through on the top and end up getting 6, 0, 0, 0, 0. I multiply everything through on the bottom. I get 3, 6, 0, 0. I look at all the top units. Canceled, canceled, canceled. We just have a meters left. I look at all the bottom units. Canceled, canceled, canceled. Just the seconds left. And I can divide those two. And when I divide those two numbers, I get 16.667 meters per second. Now that I have that written down like that, one last thing for those Sig Fig people. Technically, this only had 1 Sig Fig. So if I'm looking at this problem, well, that's the 1 Sig Fig there. And this would round it up to 20 meters per second. if I was following all the rules.